Hello out there, welcome to this video. In this series I plan on introducing some basic server architecture, and I will go over transaction script and data access object. They will be my take, so not that I invented these versions, but if you Google either of these two you will find many different variations, and I will present those that I think make sense, those that I agree with and will fit into your semester project. So that's the take. So the purpose is to introduce two architectural patterns. I call them architectural patterns versus the design patterns that you have seen in class, because these sort of span more broadly across the entire system. And the idea is that they're going to help you organize your server in your second semester project. But the ideas of these two patterns can definitely be used in all kinds of systems. So maybe it's valuable for SEP 3 or SEP 4 or whichever other system you're working on. So in SDJ2 on second semester, we introduce you to our JavaFX version of MVVM, the model view model pattern, and that's for the client side. But you haven't really seen much about how to structure the server side, so I figured you might benefit from that. And well, that's the motivation of making this video series. So the current situation is, well, what I often see our students do. We encourage them to do, for example, some unit testing, and then the conversation goes something like this, where they say, we've heard that we're supposed to be using unit testing and it was taught in class, and where do they do that? And I say they're supposed to test their validation and business logic and behavior of the system. And then they don't really have much of that, which is, I guess, usually just lazy, because there's always some rules you can come up with. But the main focus point, at least, should be to test the business logic layer on the server side. Sometimes we call this the model manager or business logic layer. And then what we often see in the semester project is actually that this layer just forwards data to the layer below, which puts it in a database. So the logic is just about interacting with the database, and this business logic layer does very little. And that's what I'm aiming to improve in this video. So our usual setup, again with a focus on your second semester project, you have a client and then you have a server and two separate programs. So maybe you have multiple clients running, but it's the same kind of program and they interact with the server. And if we expand a little bit or zoom in, then you're going to have different layers. So on your client side, you're using the JavaFX MVVM, so you basically have 5 different layers, which is a bit much. Sometimes you skip the model managers if you're being bold. Usually you don't really need these for much when you're doing client and server, at least. And then on the server side you also have some layers. This is usually what the students figure out, maybe by themselves or maybe they're prodded along, but we have different responsibilities. The server accepts incoming connections and requests, and then we have whatever's supposed to be logic down here, and then some data access which talks to the database. And this is a pretty classic approach called n-layered architecture, and here we have 3, but you can have more layers, so that's the n. Up here we have 5 layers, but we want to be more structured than just organizing stuff into separate layers. So we're going to focus on the server side, and the question is, how do we structure this layer, the model managers, our business logic layer, and how are we going to structure this layer here, the data access layer? And a classic example of what kind of stuff we're going on is this class diagram of a kind of vertical cut. So we're working with some kind of task. You can create tasks and complete them and update them and so on. Scrum, for example, have tasks, or a to-do list, that kind of task. And your server has some methods which we are less interested in. And then you can create tasks and you can update existing ones and you can delete some, and then you can get them in some way, maybe some arguments to not get all of the tasks, but maybe just by filtering something. But you have the basic create, read, update, delete, which gives us CRUD operations. And then you have the implementation, and it talks to a task data access, which sort of has the same thing. So these two interfaces, the task service, I call it a service. We'll get back to that. This interface and this interface basically has the same methods. And we also see that if you're using RMI up here, then you have a similar interface, same methods, same CRUD methods. But for example, what does it mean to update a task? You have multiple pieces of data on the task, field variables. You have perhaps in my example at least, you have a title. Maybe this is the actual user story. Then you have a description of the task. So more elaborate. What are we going to do here? Maybe it's assigned to a user. Maybe there's an estimation in story points or hours or whatever. Maybe there's a status. Is it started or finished or in progress or whatever? Other kinds of statuses being tested, whatever you have. Maybe there's a priority on it, high, medium, low, or nice to have, or must have, and so on. So there can be many different things, and I can update each of these independently, usually, but it all goes through the same update method. So maybe this update method is handling a little too much, and you're going to need a bunch of business logic, because there are usually rules for each of these. The title cannot be empty, the description might be empty, but maybe there's an upper bound. Can it exist without an assignee? Can I reassign a task, or is there some logic associated with this? The time estimation, maybe it can only go down, maybe it's okay to go up, but certainly it cannot be negative. Status, maybe it can only progress in one direction, so from not started to in progress to finished, but we cannot go from in progress back to not started. So there are rules here. Priority, I don't know, maybe this is pretty free, but all of these rules must be implemented in the same method. And that means if you're sort of doing this one by one, then you're going to modify the same method over and over. And essentially it seems to be handling a lot of stuff. And then what I see is that these rules are often ignored. So your system can just do whatever. And maybe that's not super great. So I call it task service to go back to this, but maybe you call it task model manager in the examples you've seen from class. But service seems to be the widely used name for this, so I'll stick with this this name. It's the same thing, whatever you call it. The responsibility is the same thing. Let's take another example of update. Right, I have a customer. I want to update the customer. Maybe I give it a customer object, or maybe I give it all this stuff that I can update. And I would find a customer using my data access object, the pattern that we will look at next. And then we will just set all this stuff. Right, set the first name, the argument, set the last name, the first address, the second address, and so on. All of these, and then we save it again. So every kind of change that we can do to the customer, it is only handled by one method. Maybe we only want to change the things that actually has a new value, so I would have to check if customer first name is not null, then I call customer set customer first name. If customer last name is not null, then we call this one. If customer street address this one is not null, we call this one, just so we don't update anything that shouldn't be updated or doesn't have a value, because maybe I only provide values where there is a change, so I can just give it a bunch of null values, but that's not even clear because it just does everything. So how do we even use this method? Do I have to provide all the existing ones except if I change the primary email address? Well, no one knows. After a week they have created this method and then they forget because it's not super clear, and it just does, everything. It saves the customer no matter whether it's an existing or a new one. Maybe if you cannot find something, it should create one. I don't know. I stole this example from a book, so last name is changed, or is it a new address? Two very completely different things, and you should have, checks. Last name can be one letter. I don't know if that's valid. A new address, maybe you want to verify that this has a correct structure. Maybe you have a new home phone number, or maybe the home phone number is discontinued, or maybe there's a mobile phone number. Maybe these are 3 different things that needs different kind of logic. Maybe you switch from Gmail email address to some company email address because you got a new job. So there's some context going on that we might need to consider. So the method just does everything, and that's essentially what we're trying to avoid. We don't want an update customer method. So everything is maybe a bit too much responsibility. So the second pattern which we're going to apply will attempt to break this out into separate methods. Right, so back to this diagram again. For this part here, the domain layer, the business logic layer, we're going to apply the transaction script, or at least one variation of it. And then down here, we're going to apply the data access object, a variation of that. All right, so that's the first video, the introduction of what we're going to do. In the next one, we will take a look at the data access object pattern. See you then.